Okay, this is the last part of 4.5 and 4.6a, so talking through the complex conjugates theorems and the irrational conjugates theorems. So we're going to do two problems most of the way through that need you to use both of the conjugates theorems. So I'm going to get you all the way through the factored form, and then I'm going to show you the final answer. So if you choose to take the time to distribute it all the way out, you are welcome to. But I'm going to get you to factored form, show you what it would be if you fully distributed it. And then there'll be a couple independent problems, 3 of them. And I am not working those out at all. I will just give you the final answer so that you can see where you're doing well and what you need to work on. Okay, so number 5 says write a polynomial of least degree with rational coefficients. So standard form, a true function, leading coefficient of 1, zeros at 2, 2i, and 4 minus root 6. So when you need to write out a polynomial, you need to start by identifying all of the zeros, the given zeros, plus any unspoken zeros that you would use because of those conjugates theorems. So we have zeros at 2, that was given. We have a 0 at 2i. Hopefully you remember. Excuse me. That the complex conjugates theorem says that if you have a positive imaginary, you also have a negative imaginary, so negative 2i. Given to us is 4 minus root 6, and our complex conjugates theorem tells us that if you subtract a complex, you must also add that complex, so we also have 4 plus root 6. So there are 1, 2, 3, 4, 5 zeros. Those zeros are used to write the factors. So we have x minus 2, x minus 2i, x minus negative 2i, x minus 4 minus root 6, x minus 4 plus root 6, and we have some that we need to simplify down. So this becomes x plus 2i, so we should see that complex conjugate, so x minus 2i, x plus 2i, so it's still following that theorem. Right, and our irrationals, so we have x minus 4 plus root 6, and x minus 4 minus root 6, again following that complex conjugates theorem. So if we add an irrational, we must also subtract that irrational. Using those factors, you can write factored form. So this function in factored form can be represented by x minus 2 times x minus 2i, x plus 2i, x minus 4 plus root 6, x minus 4 minus root 6. So when you distribute those out, you want to distribute the like factors first. So I would first distribute the far right two because they are both irrational factors. Then distribute these next two because they are your complex factors. And then distribute your x squared last. So these I would distribute first. And simplify, and then you're going to distribute the second. And then you would simplify those. you would actually, after you do that, so simplify each of those. Then you actually want to distribute their two simplified terms together. Okay, third. And then this one up here, you distribute last. All right, so that's your fastest process. So distribute your irrationals and simplify it all the way down. Distribute your complex, your imaginaries, simplify it all the way down. Distribute those two together, and then lastly distribute that binomial. If you do that, so I'm not going to do the entire thing, but I'm going to show you the final function. So if you want to do it on your own, you can, but I trust that you can distribute things. I have 5 zeros, 5 factors. So I am going to start with x to the 5th. That leading exponent there tells me the number of factors. So in whole, this would simplify all the way down to x to the power of 5 minus 10 x to the 4th plus 30 x cubed minus 60x squared plus 104x minus 80. That's where you should end if you distribute that fully out. All right, so let's do another one, and we'll talk through each of the steps. If you want to fully distribute it, you can.